Good morning, dear friends. I am Dr. Reginam Linus from School of Electrical and Communication Sciences at JSPM University, Vagoli, Pune. In the last session, we have seen the rotor attached reference frame of electrical machine, wherein the rotor variables are as such. At the same time, the stator variables are fictitious in the rotor. That means we are transferring all the stator variables to the rotor, but the rotor is as such. So the reference frame is rotating in the speed of the rotor. So, and the reference frame is rotating in the speed of the rotor. So the stator variables are fictitious in the rotor and the rotor variables are as such. So we have seen that in the derivation, first we have to convert natural reference frame alpha beta ABC to alpha beta, then alpha beta to DQ. So the two sessions, in these two sessions, we have seen that is a lengthy derivation. How to do this ABC to alpha beta, then alpha beta to DQ, and different matrix multiplication, everything. So this is the time consuming and the tedious process. So in this today's session, we are going to write the electrical machine model in the rotor reference frame through the observation. We are going to directly write the equation in the matrix form of rotor attached reference frame.
So as I explained already, this is the red line is the rotor axis. That means dr and qr, and then the stator axis will be ds and qs. Now we are moving all the stator variables to the rotor. Stator variables to the rotor. Therefore, we will have only the red color axis only. Accordingly, if we draw this like the reference frame axis is like this. So we have this is dr and this will be qr. So already we have the rotor voltage vdr and the vqr, and we are moving this ds to this dr. So that is why let me take in another same color of the black, so that this is will be the rotor stator, and this is fictitious here, so that's what I am writing vdsf. Similarly here the rotor, that is equal to VQSF. So now the stator windings are fictitious here. So the rotor angle between the stator and a rotor is will be theta r. Now I am going to draw this, write this equation in 3 cross 3 matrix. So this is the VDSF and VQSF and V naught SF, then VDR, VQR, V naught R. Why? These three are fictitious in the stator, in the rotor, and the rotor windings are as such. That's what I have mentioned F. So now we have a 6 cross 6 matrix, 6 cross 6 matrix, and then we have 6 cross 1 matrix. So that is nothing but IDSF and IQSF, then I naught SF, then IDR and IQR and I naught R. Now as I in the previous section, when I explained the stator attached reference frame also, I already explained one the matrix by observation. So you can refer that video as well for better understanding. However, I already told you this are having 6 windings. So we are having 4 windings, and additionally we are having zero sequence component as well. So now VDS, the stator winding is having own resistance. Similarly, here also R is own resistance, and this will be RS, and rotor winding is having own resistance RR and RR and um, RR, plus the stator winding is having own inductance. So inductance drop, how we will write? L S into d by dt. The d by dt we can d by dt of IDSF. So I will write it shortly P. Already you know that P is equal to d by dt. Similarly RS plus LS into P. Then similarly here RS plus LS into P. Why this LLS into P? It is a zero sequence component. In the zero sequence component will not contribute any magnetizing. Similarly, magnetizing effect. Similarly, here we can write LR into P plus LR into P plus LR into P. So now this entire diagonal matrix will be over. Then if you see this here, we can for simplicity we can write here DSF and D DSF and QSF and not SF, then DR, then QR and not R. So we can now DSF. So this is now these three windings are fictitious. You know, these three windings are fictitious. Fictitious. So imaginary. In this session, it's in the last session itself, when I explained the observation method by in the stator attached reference frame, I already told you the fictitious winding, if both are perpendicular, there is having a speed EMF term, fictitious winding. So now these three windings are fictitious. If the two windings are perpendicular, so we will have a speed EMF. Now if you see here, this DSF and QSF are perpendicular, so we will have the speed EMF term. So both are self-inductance, so we can write LS into omega R. Omega R is nothing but what? Omega R is nothing but d theta by dt, d theta R by dt, the electrical speed of the rotor. So now Ls into omega R. Then at the same time, zero sequence not contributing anything. So now I am writing all zero sequence component except this diagonal values all are 0. So now we have finished the zero sequence component. Now we have DSF. DSF means what? The stator direct axis of the stator and the direct axis of the rotor. So stator and rotor winding VDSF and VDR both are in the same axis. So same axis means what it will be occur? Mutual inductance will occur. So we can write mutual inductance between stator and rotor and P. We will know already L into di by dt, like that we will write. Then VDSF and VQR. What is VDSF? That is speed EMF. We are writing now equation of the fictitious winding. So fictitious winding, if both the windings are perpendicular, when we write the equation for fictitious winding, both the windings are perpendicular, we will have a speed EMF term. But here what happened? VDSF and VQR, that means stator winding and rotor winding. So what inductance will come? We will have the mutual inductance will come to the picture. So MSR into omega R into, then final term will be IQR, that is a speed EMF term. So speed EMF term is nothing but inductance into speed into current. Inductance, speed in the current. So now we have written this. Then next VQSF. So VQSF and DSF. So QSF and DSF both are perpendicular to each other. Obviously we have a self-induct speed EMF term, but both are self-inductance. Both are the stator winding. Therefore stator winding inductance in the omega R. Then Then QSF, obviously there is no effect of zero sequence component. So directly we can write the zero sequence component effect also 0. Therefore, we will no need to be worry about that zero sequence effect. Now, when we see this QSF, that is QSF means what? Quadraxis winding, quadraxis stator winding, it is fictitious in the rotor. So QSF, DR, that is the direct axis winding of the rotor. So this is fictitious winding equation. So surely we will have a speedy EMF term. The speedy EMF term will be MSR into omega R. Then QSF, QR, rotor winding and stator winding both are in the same axis. So we will have mutual inductance in the di by dt of the particular current IQR, then 0. QS and zero sequence component. So zero sequence component here also we will have the zero values. So we can write it here zeros. Then now we can move all the three rows are filled. Then we can go to VDR. VDR and the DSF. That means what? Direct axis current of the direct axis of the rotor and direct axis of the stator. So both are in the same axis. See, DSF and DR both are in the same axis. So we will have mutual inductance effect. So M in the MSR in the P. Then DR and QS. So this is not a fictitious winding. These windings are as such, not like previous winding. So whenever this DR and another windings are perpendicular, there will not have any speed EMF term. Why? It is not fictitious. So now we have filled this. Then DR and QR, that also both are DR and QR. Both are DR is here, QR is here. So both are perpendicular to each other. So the value will be 0. Then QR and DSF. QR is rotor axis and DS is stator axis. Both are perpendicular, again 0. Then QR and QS. Both are in the same axis. QR is the rotor axis and QS is the stator axis. Both are in the same axis. QR and QS, the same axis. So automatically we will have the mutual inductance between stator and rotor in the di by dt. Then we can have, this will be automatically QR and DR both are perpendicular. So we have 0 value. Then if you write this V naught, already we know V naught, there is not having any other contribution. So all are 0. Then, so this is the matrix. Then one more important task is writing the sign. How to write the sign? So now here we are moving the stator variable to the rotor, right? Stator variable to the rotor. So when we move the stator variable to rotor, this ds, this d value is ds and qs when we are moving this. Therefore, d is lagging with respect to q, right? When we are moving this side, d is lagging with respect to q. Therefore, the speed EMF of dx is having minus sign. So here one minus and this term will be the minus term. So this what we can, from this we can understand the winding equation, that three-phase electrical circuit, electrical machines winding equation in stator rotor attached reference frame, where the d axis speed EMF term having minus term, since when we transfer the rotor stator variable to the rotor, we can have this rotor, this d axis component will be lagging when compared with q axis component. So so that's why we are having the minus term. So from this I am concluding today the the modeling of electrical machine by stator at rotor attached reference frame. So I hope this topic is very much helpful and easily you can understand how to write the equation in the by using observation. The next class I will explain how one can derive the torque equation from this entire matrix. So those who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.